This video tutorial will look at LED lights in short, look at the definition, the uses, the pros and the cons, and some illustrations of LED lights. LED stands for light emitting diode. An LED is a semiconductor that emits light when activated. It's used in traffic lights, street lights, in homes, in businesses, televisions, and also in automotive applications like brake lights and so on. The pros are it's very reliable. It can last up to 3 to 5 times as long as traditional incandescent bulbs. Some are even expected to last as long as 50 times compared to incandescent lights. Now that's awesome. Robust LEDs are solid state, that is, not like traditional tubes or bulbs. They are far less likely to suffer failure from damage. For instance, just think how fragile a bulb is. The size, it is tiny compared to the large old incandescent lights which we know. It can fit into much smaller spaces. Efficiency, they don't use as much energy as traditional bulbs and can produce a saving of up to 60-70%. The cons, the cost initially for manufacturing these bulbs compared to traditional bulbs is quite high, but like in technology and manufacturing, everything comes down as development progresses. The breadth of the light compared to other lights, it's like a more focused light. It could be an advantage, in fact, but to an extent one couldn't see this as a con. I've just illustrated how a dynamo, simple dynamo, works. It's just a component with plastic gears and an arm which would spin the gears in the required ratio. What we have here is just a little motor. Got magnets which sits on the outside and a copper armature on the inside. So as the copper wire spins and rotates on the inside, an electrical field is generated, and we will have a current which runs from those 2 points, the positive and the negative pole. So if we attach those to the dynamo like so, and turn it quickly, we can generate power for this LED light. LED light, it's a flat light with about 6 LEDs installed in them. An LED is light emitting diode and uses the minimum amount of electricity, and it's just an amazing piece of equipment for a sustainable house. We have a range of light bulbs on the screen. The typical incandescent light, which we've known for many years, which glows and produces a lot of heat, which doesn't make it that inexpensive to run. However, we have progressed to the fluorescent type of light, which we call the energy saving lamp or light, and now at this stage LEDs are being produced. LED, which produces hardly any heat. This is a typical lamp compared to the incandescent one. The only difference is we have some LEDs in there, which is extremely energy efficient. I have a strip light right there, and it's in a tube, as you can see, with little chips. I'm going to switch on the strip light now just to illustrate. We have a white strip light, and then of course connected to it is a yellow strip light, and it's just a tube with those LEDs or chips which are connected with wires and are extremely energy efficient. These got many purposes in a building or around a house and will save heaps of power. I've powered up the LED, the downlighter, which are most commonly used in buildings, and it's a 12 volt 1 watt bulb, and very energy efficient, and an awesome choice for a building. Here we have a chandelier with candle shaped LED lights, specially designed for chandeliers, which are very energy efficient. This chart shows the lifespan or the life expectancy of different types of lights over here. We've got the yellow line, very short, the incandescent lamp. Let's just have a look at the axis quickly. This is the lifetime in thousands of hours, about 100,000 hours. That's about 10.25 years. And here we have the lumen flux output. That's the amount of light that's emitted from the lamps. Secondly, the energy tube sits over there. There you are, the energy tube. 5mm LED. It drops to about almost a year. A metal halide lamp is the yellow dotted line right there, to about 2 years. We've got a halogen lamp which sits there, very short lifespan. We have fluorescent lamps which sits there, about 2, almost 3 years is the span. And a Kingston LED light, the blue line right there, has got a lifespan of about 10.25 years. And in 2016, so the top companies predicted that the LED lights would last up to 20 years. So in conclusion, we can see that LED lights is a must for a sustainable building within a sustainable architectural context. We're looking at LEDs, and LEDs could be powered by batteries and photovoltaic panels, and I just like to put that in context as a renewable energy source compared to oil, coal and natural gas, which are fossil fuels. On the screen we have the energy at 1000 terawatt hours per year on this axis, and we have the progression of the years from 1970s to 2010 and up to 2013. Now we can see there's a big rise in fossil fuels, oil, the red line, coal, the black line, and light blue, natural gas. Nuclear is the orange line down there, and what we are interested in is other renewable energy sources, which lies right there. And as you can see, it's been very low over the years and only picked up to about 1 to 2% in 2013. Next, I would like to show how many barrels of oil the world uses per year. Now, if we have a look at this axis, we see that the energy is 1000 terawatt hours per year, and we have 15 and 20,000 terawatt hours right there. So let's just look at this one line, the oil consumption. So it sits at about 18,000 kilowatt hours per year. Let's use the online calculator to see how many barrels of oil that is. Just to get an idea of the amount of oil being used in 1 year, I've used the online calculator here from the conversion website. I've typed in 18. It calculates terawatt hours to barrels of oil equivalent. So I've clicked on convert, and as you can see, we have 18 terawatt hours, and that equals, if we have a look at that number, it's 10.5 million barrels of oil in 2013. 10.5 million barrels of oil. And we're going to go back to that chart and see how it rises. Back to the world energy consumption chart. Our objective should be to get this red line, oil, this black line, coal, and this light blue line, natural gas, down. It's rising, but we should try and get that down. We should endeavor to get the blue line, hydropower, and the green line, which is other renewable energy sources. We should try and get that up to cancel or to balance it out. This chart from the 2014 Global Status Report gives us an idea of fossil fuels in context of renewable energy, which sits over there. We have fossil fuels of 78.4%, which is that segment which is oil, that segment which is coal, and that segment which is natural gas, which is more or less about a third and a third and a third of fossil fuels. So as we can see, it's almost 80%. Now, this segment, the green one, shows renewable energy, which is 19%, and we see nuclear at 2.6%. If we take that segment out and we analyze it, the renewable energy source, looking at the renewable energy component, which is about 19% of the 100%, we're going to look at just a quick look at all the different areas. Traditional biomass is 9%, bioheat is 2.6%, ethanol 0.34%, biodiesel 0.15%, biopower generation 0.25%, hydropower 3.8%, wind 0.39%, solar heating and cooling 0.16%, solar photovoltaic 0.077%, solar CSP, that's concentrated solar power, 0.0039, geothermal heat 0.061, geothermal electricity 0.049%, ocean power 0.00078%. So just focusing on solar photovoltaic panels is 0.077, it's less than 1%. And let's focus on wind power, which is 0.39%. So in the context of LED lights, which could run from batteries being charged either by wind power or solar photovoltaic panels, we can see that this is not even 0.5% wind, and photovoltaic power is not even 8%. So as we can see, it's extremely low. So within a LED context, wind and photovoltaic panels and LEDs, we can see that the world has made some efforts to phase out incandescent bulbs or lamps and get into LEDs. Now you can just imagine the impact that would have. It's small, but it will have a huge impact on the energy and the resources of our planet.